Hello chemistry students, welcome back to my chemistry kitchen, and today we are going to study stoichiometry. In studying stoichiometry, we're looking at what happens to the amount of reactants that you're able to produce when you change the amount of reactants that you have. And you can even flip it over. If you want a certain amount of product, you can determine using stoichiometry how much reactant you need to begin with. So what you need to do is first make sure that you have all of your necessary materials. Go ahead and grab your chem helper, or you can pull it up from Canvas because that's where I have created an electronic copy of this chem helper. And you should also pull up your handout called Fun with Baking Soda, which I posted to Cami, or your teacher may have posted it to OneNote. So go ahead and do that now. And if you don't want to write on your computer, you just want to take notes as we go along, then you should grab a pen or a pencil and a piece of scratch paper. Oh, and don't forget a calculator. So go ahead and get all of those materials, put me on pause, and then we'll start. Okay. So hopefully you're back and you've got all of your materials handy. What we're going to do to study stoichiometry is the decomposition of baking soda, and that's what I have here on my whiteboard. So after the first paragraph on your handout, Fun with Baking Soda, you should write out this balanced equation. We have 2 moles of sodium bicarbonate. When it decomposes, yields 1 mole of carbon dioxide, 1 mole of water, and 1 mole of sodium carbonate. And I know that I only have 1 mole of each product because I do not have a coefficient in front of the compound. So in chemistry then, we just assume that our coefficient is 1. Now, when we do this in the lab, I just wanted to in the lab, it's in my chemistry kitchen that we're going to do this, but I just wanted to mention that the only solid product that we're going to get here when we decompose baking soda is sodium carbonate, because my carbon dioxide and my water are gases at the high temperature that we're going to have in my oven, which is 400 degrees Fahrenheit. All right, so let's look at number 1 on our handout, Fun with Baking Soda. It says study the equation above, which is what I'm talking about right here. How many moles of sodium carbonate are going to form when you decompose 2 moles of sodium bicarbonate? All you have to do to answer that is look at your equation. Since I start out with 2 moles of sodium bicarbonate, we just have to look at my coefficient for sodium carbonate, which in this case, there is no number here, so we assume that it is 1. That means that when we decompose 2 moles of sodium bicarbonate, that we're going to end up with 1 mole of sodium carbonate. 1 mole is your answer to number 1, so go ahead and write that down. Number 2 says if you had 2 moles of sodium bicarbonate, so if we start out with 10 instead of 2, how many moles of sodium carbonate would you produce? In order to answer that, we're going to use something called the mole ratio, which is determined from my balanced equation, which, I happen to have right here on my whiteboard. So according to my mole ratio, if I have 2 moles of sodium bicarbonate, that is equal to 1 mole of sodium carbonate. What this means is whatever amount of sodium bicarbonate we begin with, we're going to end up with half of that amount of sodium carbonate. So if I start out with 10 moles of sodium bicarbonate, all I have to do is divide that by 2, and I get 5 moles of sodium carbonate. And how did I know to divide this by 2? By looking at my mole ratio. 1 is half of 2. Therefore, however much I start with on my reactant side, I'm going to end up with only half that amount on my product side. So this is what I call the logic way to solve this problem. But there is another way to do it if you prefer with math, and this is with writing out a proportion. Now we've already learned how to write out proportions in order to solve mole problems, but once again we're going to go ahead and do this. So what is given in our problem is that we have 10 moles of sodium bicarbonate, and I want to know how much sodium carbonate we're going to create, but I don't know that answer yet. So I'm going to put 10 moles of sodium bicarbonate over X moles of sodium carbonate, because I don't know how much I'm going to be able to produce yet, but we will find out. All right, so now I'm going to make that equal to my mole ratio. So as I mentioned before, I'm going to get my mole ratio from my balanced equation. So I'm just copying down the coefficients that I have in my balanced equation. So I have 2 moles of sodium bicarbonate, because I have a little 2 in front of here. And if I look at sodium carbonate, I have only, I've got no number there, so that means I've only got 1 mole of sodium carbonate. And now I'm done setting up my problem. Now comes the easy part. I have to solve for x. And in order to do that, I need to cross multiply and divide. So I get 2x equals 10. And to isolate x, I have to divide each side by 2, and I get x is equal to 5. This isn't my final answer, though. You've got to give me the units, and you've got to give me the compound that we're talking about. So go back to your proportion. Find your variable. Here it is. It's the letter x. I'm going to copy down the unit, which is mole. I'm going to copy down my compound, which is sodium carbonate. And that is my final answer. Notice that my final answer is exactly the same as what I figured out using the logic way, using just the mole ratio. So you can do this either way. You don't have to do a proportion if you can think it through. If you do need to use a proportion, I'm totally fine with it. You should do whatever it takes to get you the right answer. All right, so I'm going to erase all of my little stray marks here. Now, let's look at number 3. Number 3 says, if you wanted to make 7 moles of sodium carbonate, how many moles of sodium bicarbonate do you need to start with? So now we're kind of going in the opposite direction. Instead of me telling you how much we're starting with, I am telling you how much we want to end up with. So we're going to kind of work a little bit backwards. So my problem says I want 7 moles of this compound. So let's think about this logically. We know that the mole ratio is 2 to 1. The amount of moles of sodium bicarbonate and how much sodium carbonate is produced. Well, I want 7 moles of sodium carbonate according to problem number 3. But according to my mole ratio, however much sodium carbonate I want, I need to start with double the amount of sodium bicarbonate. So what's 7 times 2? Well, that's 14. So that means that we should start out with 14 moles of sodium bicarbonate in order to end up with 7 moles of sodium carbonate. So again, this is the logic method of solving that problem. But for some of you, you might not see the logic there, and that is totally fine. For some of you, you need to use the proportion. So let's start out with what we're given in the problem. The problem says that we want 7 moles of sodium carbonate. So let's start by writing that down. 7 moles of sodium carbonate. And we want to know how much sodium bicarbonate we need to start with in order to obtain these 7 moles. Well, looking at the equation, we don't have that answer. We know how many moles of sodium bicarbonate we need to start with in order to get 1 mole of sodium carbonate, but that's not our problem. The problem is we want 7 moles of this stuff, so we don't really know how many moles of sodium carbonate we need to begin with. So I'm going to put the letter X here. I'm going to make that equal to my mole ratio, which is exactly what I have in my balanced equation. So since I have moles of sodium carbonate on top on the left, I'm going to put moles of sodium carbonate on the right. That's a 2 right there. What's my coefficient? It's a 1. So I'm going to put a 1 there. On the bottom on the left, I have moles of sodium bicarbonate. So I'm going to put moles of sodium bicarbonate on the right. And now I have to write down my coefficient. Oh, it's a 2. So I'm going to put a 2 here. Awesome. Now I have my proportion all set up. And in order to solve for x, I need to cross multiply and divide. So 1 times x is x. And 7 times 2 is 14. And then I need to look back at my variable and copy down next to my answer my unit, which is mole, and my compound, which is sodium bicarbonate. And this is my final answer. Notice I got the same answer using the proportion as I did using logic. So once again, you can use either method. As long as you get the right answer, I'm totally good with it. Okay, so that is questions 1, 2, and 3 finished. Now, let's decompose some sodium bicarbonate, and we are going to make some sodium carbonate. So we're going to run this reaction, and we're going to see how much sodium carbonate we can actually produce. Okay, hold on a second. All right, everybody, I am back. So we are going to run this reaction, like I said, and it calls for 2 moles of sodium bicarbonate or 2 moles of baking soda. But I don't have a scale in my kitchen that actually measures moles. So instead, we need to figure out how much does 2 moles of sodium bicarbonate weigh in grams. So that's what I've got up here on my board. So in my formula for sodium bicarbonate, I have 1 sodium, which is 22.99, and I have 1 hydrogen, which is 1.01. I have 1 carbon, which is 12.01 grams per mole. And then I've got 3 oxygens, and 3 times 16 is 48. And so when I add all of these together, plus 1.01 plus 12.01 plus 48, that means that I get 84.01 grams per mole. So this, though, is the amount that 1 mole of sodium bicarbonate weighs. But look at, according to my equation, I need 2 moles. So I need to multiply this by 2. And what I get then is 168.02 grams. So I need to weigh out 168.02 grams. So let me move this over. And as you can see here on my counter, I've got my tiny little scale here. And I've got some baking soda in there that I've already weighed out. But my problem is that I've only got second. Oh, there we go. Sorry about that. My problem is that I've only got enough baking soda to use 1 mole of baking soda. So let me show you how much I've got on my scale here. There we go. It's like 84. Well, it was 84.01. Right now we're just gonna use then 84.02 since that's what this is showing right now. But I just wanted you to see exactly what I have here. So anyway, I've got 84.02 grams, which is actually equal to only 1 mole of sodium bicarbonate. In fact, it's just a little, like a 1/100th more grams of a mole of baking soda. And so my question is, like, if we don't run this reaction with 2 moles and only 1 mole, how many moles of sodium carbonate can we expect to make? Well, since I cut my initial amount in half, I need to cut the amount of sodium carbonate in half too. And what is half of 1? Well, half of 1 is 0.5. So I should really only expect to make 0.5 moles of sodium carbonate. All right, so great. So that is actually... Okay, so let's go through your problem set here. So number 4 said the equation needs 2 moles. 2 moles of sodium bicarbonate would be 168.02 here. But I don't have enough. So I've only got about 84 grams of sodium bicarbonate. So that's equal to 1 mole. So 1 mole should be your answer to number 5. Number 6 says if I start out with 1 mole of sodium bicarbonate, how many moles of sodium carbonate can I produce? And your answer is here, 0.5 moles of sodium carbonate. And so I don't really have a scale that measures that. What do I need to do to make that amount of sodium carbonate measurable? Well, all I need to do then is just use division. And I guess like multiplication. So here's what I need to do. I need to figure out how much a mole of sodium carbonate weighs and then divide it by 2 so that I can determine how many grams of it I can make. Because like I said, I don't have a scale here that measures moles. I only have a scale that measures grams. All right, hi again. All right, so back looking at number 6, it says that if we start with 1 mole of sodium bicarbonate, how many moles of sodium carbonate can I expect to produce? And we already said that that would be 0.5 moles. And number 7, I don't have a scale that measures moles, so what do I need to do to make that amount of sodium carbonate measurable? Well, I first need to change moles to grams, and then I need to divide by 2. So here's what I did on the board then. I figured out how much 1 mole of sodium carbonate weighs in grams. And so I've got 2 sodiums, and 2 sodiums is 2 times 22.99. And remember, I got 22.99 here from my chem helper. And then I'm going to add that to 1 carbon and add that to 3 oxygens. And 3 times 16 is 48. And then I add this all up and I get 105.99 grams in 1 mole of sodium carbonate. But the problem is that I don't get 1 mole of sodium carbonate. I've got only half a mole of sodium carbonate. So to figure out how much sodium carbonate I'm going to get, I need to divide the mass of 1 mole by 2 in order to get the mass of half a mole. And 105.99 divided by 2 gives me 53 grams. So I need to, I could expect, I guess, to create, after I run this reaction through, 53 grams of sodium carbonate. All right, so that's what I'm going to do. I'm going to run this reaction, and we're going to see if we can create 53 grams of sodium carbonate by decomposing 1 mole, or 84.01-ish grams of sodium bicarbonate in the oven. And so here's what I'm going to just move this off so that you can actually see what I'm doing. And so here is what I'm going to do. I'm going to use my little stoneware plate, and I'm going to weigh it on my scale here. And if I take a look at the dial, where it landed, let me see where we are at. We are at about 750 grams. I'm just going to write that up here just so that we have it. So 750 grams is, whoops, sorry, I lost you. 750 grams is the mass of my plate, and I already showed you how much baking soda we are going to use, which is about 84, I think it was like 84.06 grams. So what I'm going to do is pour this baking soda out on my plate. I'm going to try to, whoops, oh, that went on the floor. Get as much out of my little coffee filter here as I can. And I'm just going to spread this out a little bit in order to increase the surface area to make sure that as many of my molecules of sodium carbonate are going to be exposed to the heat in my oven as possible. And so what I am going to do then, and I will show you. Okay. So here's what I did. I just kind of put all of the sodium bicarbonate out on my plate. And next, I've got my oven at 400 degrees Fahrenheit. And I'm just going to put my plate of baking soda into the oven. There we go. So it's just going to sit in there. I'm going to set my timer here for 30 minutes. And I think that that should be enough time for my baking soda to decompose in order to form some sodium carbonate for us. So while we're waiting, go ahead and pause this video because I would like you to try and answer one of the next questions on your handout. So the question is, how might you use stoichiometry in your kitchen? So I'm going to put you on pause. Think about how you might be able to use what you're learning here so far in your own kitchen. Okay, well, I was hoping that that you would have thought about how you could use stoichiometry in your own kitchen, just so that you know my baking soda is still decomposing in my oven. But I just wanted to say, like, I was just thinking about how I use stoichiometry in my kitchen. For instance, most of my cookie recipes give me a yield or a product. Like after I mix all the ingredients together, they give me a product of 24 cookies. But I gotta tell you, that's usually not enough for me. If I'm gonna take the time to make a batch of cookies, then I want like 48 cookies. I want double that amount. And so in order to get the result that I want, in order to get the product that I want, which in this case is 48 cookies instead of 24, then I have to double, since I want double the amount of product that the recipe calls for, I need to double all of my ingredients in order to yield double the amount that the recipe actually calls for. And so that's how I use stoichiometry in my kitchen. And so hopefully you were able to come up with a similar example of how you could use stoichiometry in your kitchen as well. All right, so I'm going to put this on pause until my timer dings. And then we'll see how much baking soda, not baking soda, how much sodium carbonate I have actually produced. All right, everybody. So I took our baking soda out of the oven and it has been cooling now for, I don't know, almost like 25 minutes. So now I'm going to transfer it from this plate onto my coffee filter that's on my little scale. And then I'll show you how much we have left. Okay, guys, so here's the plate that I took the sodium carbonate off of, and then those are the utensils that I use. There's a little bit that's still on there, but just wanted to show you. This is how much we got from our decomposition of baking soda. So what we've got left from our 84.06 grams is 53.13 grams.